All right, so this is day 2 of the final exam review. We ended yesterday at number 11. Today we're doing numbers 12 to 23. Okay, so actually 12 to 22. What am I saying? So we're gonna basically do those, and then we'll stop. Tomorrow we'll continue 23, 33, etc. So this is a working together problem. You can see it starts off with working together, right? So Dan and Steve can pick up 20 bushels of apples in 5 hours. Had he done it alone, it would have taken Steve 9 hours. How long would it take Dan to do it? So first off, you need to remember the formula for this. So total time is equal to x times y over x plus y. Okay? So total time is equal to x times y over x plus y. So the time it takes them to work together is based on that equation, okay? So let's kind of start and assign some values. So it says Dan and Steve can pick up 20 bushels of apples in 5 hours. So it takes them together 5 hours, okay? So I'm going to put 5 right here. It says, had he done it alone, it would have taken Steve 9 hours. So let's just say Steve is x. So it'd be 9y over 9 plus y. How long would it take Dan to do it? So we know how long it takes them to do it together. We just don't know how long it takes Dan to do it by himself. So Dan would be the y variable. Steve would be the x variable. So I just plugged in the numbers. Now I'm going to multiply this over. So that gives me 5 times 9 plus y is equal to 9y. I'm going to distribute. So 45 plus 5y equals to 9y. Then I'm going to subtract my 5y over to the right side because 5 is less than 9. So that's going to allow me to kind of subtract on the right side. So let's move that over. That's 45 equals to 4y. And then if I divide both sides by 4, so 45 divided by 4, that's 4y divided by 4. Y is equal to 45 over 4, which is, what would that be, 11 and a quarter? Yeah. So it'd be 11.25. That would be my answer for this. Okay? So this is, I don't know if you guys remember, there's 2 types of working together problems. The one we just did is considered the harder one. The harder one is always the one where they tell you how long it took them to do the work together, how long it takes one person to do the work, but they don't tell you how long it takes the other one to do the work. That one's considered the harder type of problem. The easier type of problem is when they tell you how long it takes each one of them, and you just got to figure out together how much. Okay, so that's the next one. It says May can sweep a warehouse in 8 hours. Mark can do the same in 6. How long would it take them to do the work together? So I'll go ahead and let you write this down. Meanwhile, let me just write down the formula, and then I'll pause the video so it doesn't kind of eat up time there. But here's the formula that you're going to have to use. So let me just pause. All right, so May can sweep a warehouse in 8 hours. Mark can do it in 6 hours. How long will it take them to do it together? Remember, together is T. So I'm going to put T equals to. Now we'll let May be X. We'll let Mark be Y. So this is going to be 8 times 6 over 8 plus 6. So that's 48 over 14. Okay, let me just get my calculator here really quick. So 48 divided by 14, that's 3.43. What is the units? Hours? So 3.43 hours. And that's it. So this is the easy way. Okay, this is the preferred way because it's a lot easier to do it this way than the one we just did where you got to solve for one variable like X or Y. Solving for T is simpler because they give you everything you need. You just got to calculate it by adding and multiplying, and you're good. So you'll for sure going to have these type of questions, right? Maybe one of each, maybe 2, who knows? It's going to add up to over 60 problems total. So sometimes some of them will repeat. All right, so we're going back to factoring. We did this yesterday. We're going to do it more today. I think it's going to be a consistent thing we're going to do all 5 days. Factoring is very important. So they want me to solve this by factoring. Now, anytime you see that they tell you to solve and you have to factor, don't forget that the main thing is you got to set it equal to 0, right? You always want to set it equal to 0. Right now, it says it's equal to 6. So let me move this 6 over. So that's x squared minus 5x, let's be plus 4 equals 0. At this point, we're going to do the x method. One of the nice things about this problem, though, compared to the stuff we did yesterday, is that our a term is a 1, so I'm not going to have to divide. Okay, a is 1, b is negative 5, c is 4. So x method would look like this. 4 on top, negative 5 on the bottom. Okay, so now I'm going to use a positive, I'm sorry, not a positive 4, a negative 4 and a negative 1. Because negative 4 times negative 1 is a positive 4. Negative 4 plus negative 1 is a negative 5. Okay, so that's going to allow me to get the correct factors. So let me go ahead and write my factor here. This will be x minus 4, x minus 1 equals 0. Setting each one equal to 0, so x minus 4 equals 0, x minus 1 equals 0, I get that x is equal to 4 and that x is equal to 1. So this one's a little bit easier than the stuff we did yesterday because I didn't have to divide by anything. Since a was 1, I can skip that step. Okay? When a is not 1, then I have to divide at the end. I got to keep doing that. So kind of annoying whenever I see an a value that's not a 1 because I know it's going to take me a little bit longer. I mean, it's not that it's difficult, it's just, it's more work. So I prefer not to do more work. So, all right. So far, 12, 13, 12, 13, and 14. Any questions on those? The total working together problems, factoring, I mean, kind of like yesterday. So, all right. Solve by factoring. Again, if it says solve by factoring, you want to set equal to 0. This is one of those things you might want to put on your notes, right? Not the whole problem, but if you want to just say, hey, if you're having to solve by factoring, make sure you set it equal to 0, right? Because that's a big hint. That's how you kind of get the hints as to what to do. So I'm going to get this 5p. I'm going to move it over. So this is p squared minus 5p equal to 0. Okay, now you notice how I have two terms. So this is either a difference of two squares, or maybe they just have something in common. This is not a difference of two squares, though, because remember, even though I can write p squared as the quantity p squared, there's no way for me to write 5p as something squared. Okay, so it's not a difference of two squares, but I can take out the letter p from both of them. And once I do that, I get each product, so p and p minus 5. I'm going to set them both equal to 0. The left side is already solved for. The right side, I just got to move that minus 5 over. So here are my two solutions, okay? This one and this one right here. So this one's not too bad. Anytime you got to solve for a binomial, it's usually a lot easier because there's not so much stuff you have to worry about. So that's 15. Remember, we're going up to 22. So getting closer. Here's when we're going to start doing rational expressions. So this is kind of like, you could say, the headache of the final. Okay. Now, it says solve, remember to check for extraneous solutions. So in other words, after you find your answer, make sure you plug them back in, make sure that nothing ends up like dividing by 0. Okay. So I noticed that I can only add fractions if their denominators are the same. Okay. But the way I taught you guys to do this was to find the common denominator between all three denominators. So I have 3x squared, I have x squared, and I have 3x. Okay. And then I told you guys, okay, look at each one of these three things. In terms of numbers, they all have a 3, except for one of them. So I'm going to multiply this one by 3. That'll give me a 3x squared. Okay, the top is 3x squared. What's missing from the bottom? Well, the squared, so it's missing an x. So that gives me 3x squared. This right here is our common denominator. Okay, this is what we're going to multiply everything by so that we can cancel out the denominator and have a normal looking problem. So I'm going to multiply everything by 3x squared. Okay, so here we go. 3x squared times 1 over 3x squared equals to 3x squared. I don't know if you guys remember doing this for homework, but this was always one of those nightmare sections for me when I was learning this in high school. Like, I didn't like it. It was so much work to have to do, so much writing. And I'm a person that doesn't like repetition. So when I have to do it all the time, it would just kind of get me upset. So, all right. So I have all of them there. Now let's look at the very left side. 3x squared and the denominator of 3x squared, I can actually cancel everything, right? It's all canceled. So I can get rid of 3x squared with 3x squared. What about the middle term? Just the x squared. So the x squared with this x squared, the 3 remains. What about the last one? Well, I can get rid of a 3 and also a single x. So let me rewrite what's left over. So this is just 1 equals, that's 3 plus x, yeah. So after you do all that weird stuff, you should end up with something that looks simple, right? That's how you know you did it right. If I just subtract by 3, I'll get my answer for x. So I'm going to move the 3 over here. Negative 2 is equal to x. Here's my answer. You have to make sure that it doesn't mess up the equation. If I plug in a negative 2 into the denominator, the first denominator will become a 12 because it'll be 3 times 4. The second denominator will become a 4 because negative 2 squared is 4. And the last denominator will be a negative 6. So that's all okay. Those numbers are fine. 12, a 4, a negative 6 is fine, as long as it doesn't become a 0. Okay, because you can't divide by 0. So we checked for extraneous solutions just mentally. So this checks out just fine. Okay, this checks out just fine. Any questions on this one? I mean, it's been a while since we did this. If you need a refresher, just look for adding and subtracting rational expressions in the Google Classroom. Go to where it says notes, videos, and homework, and look for adding and subtracting rational expressions. And the lesson will be there. Or you can just YouTube it. I mean, that's the one thing that I'm jealous about your generation, is that when you don't know how to do something, you guys can literally YouTube it. And I do that. Every time I got to fix something in my car that I'm not too sure how to do, like, I can fix a lot of things. Growing up as a mechanic's son, I know how to fix a lot. But some of the newer cars with the new tech, I don't know how to fix some of that stuff because my dad grew up with carburetors, and that's not even a thing anymore. Now it's all electric transmissions and all that stuff. So, so now whenever something needs to be done and I don't know how to do it, I'll just YouTube, right? Let's see if somebody tells me how to do it there, shows me how to do it. So yeah, I'm kind of jealous that you guys have YouTube. I did not, but that would have been pretty cool. All right, we're gonna do the same thing in this problem. We are gonna write down all the denominators. So, but before we do that, let's factor, because here, the previous one, we didn't have to factor. They were just monomials. It was like an x squared, 3x squared, a 3x. Here, these are factorable. Maybe not the middle one. K plus 6 is already done. But the other ones are factorable. I can take out a k. So this will be 1 over k times k plus 6 plus 1 over k plus 6 equals 3 over k times k plus 6. I just factored the bottom. And it's a quick factor because it's just 2 terms. I just took out what they have in common. No big deal. I didn't have to do X methods or anything like that. Okay, now I'm going to write down all the denominators. So it's k times k plus 6, k plus 6, and k times k plus 6. if I want these things to be the same, which one do I have to manipulate? The top, middle, or bottom? Which one needs to change to make them all match? The middle. What do I need to do to it? Well, I get what you're saying, but not add, multiply a k, right? But I get what you're saying. You're saying put a k right there, right? Which is multiplying the k. So yeah, I understood exactly what you meant. But that is what you meant, right? To put a k right there. Okay, yeah. So yeah, and now they're all the same. So this, actually, I can just erase these equal signs. This is my common denominator. Okay, so I'm going to multiply everything by k times k plus 6. So k times k plus 6 times 1 over k times k plus 6 plus, like I said, this is the annoying part that I used to hate all the time. It's not that it's necessary. It's just for a person like me that learns visually, I need to see what's happening, so I have to write it down. If I don't write it down, I don't always comprehend. And what's the point in learning something if you don't get what you're doing, right? So this used to, like I said, this used to upset me all the time because it's like, oh, it's taking so long. All right. On the very left side, what cancels? Everything, right? This whole thing is gone. What about in the middle term? K plus 6 only. What about the last term? Everything. So here's what we have. We have a 1 equal to k, plus k, not equals to, and then equals to 3. Okay? I'm going to move the 1 over. That means that k is equal to 2. I'm going to look at my denominators, and I'm going to check to see if 2 is okay. So let's see. 2 squared is 4. 6 times 2 is 12. 4 plus 12 is 16. That's okay. That denominator works okay. The second denominator, k plus 6 at the very top here. 2 plus 6 is 8. That's fine, as long as it's not 0. And then here, k squared plus 6k for the last right side denominator. That's 4 plus 12. That's 16. So everything checks out. It's fine. Okay? So this checks out just fine. Let me see. All right, so simplify. Now this is a fraction divided by a fraction. Now remember, we don't divide fractions, we multiply by reciprocals, right? So this can be rewritten as x minus 2 over 3x times x minus 2 over 4. Instead of divided by 4 minus x minus 2, I'm going to multiply it by its reciprocal. Okay? So I'm multiplying by the reciprocal. Let me go ahead and multiply this out. I'm not going to really multiply the top. I'm just going to rewrite it like this. And then the bottom will be a 12x. And I'm done. Okay? So you don't have to expand it. They're going to leave it most likely in factored form. So that's all they would want you to do. So remember, the problem says x minus 2 over 3x divided by 4 minus x minus 2. But we don't divide fractions. We're going to multiply by the reciprocal of the bottom fraction. The reciprocal of the bottom fraction would be x minus 2 over 4. So we're just going to multiply the original fraction times the reciprocal of the second fraction. And then if you have to multiply some numbers, go ahead. If you got to combine some x's here and there, go ahead. But for the most part, if things are in factored form already, like x minus 2, you could just leave it alone. Maybe just put them together and square it if they happen to be the same. But if not, just leave them alone. That's fine. All right, before I move on, any questions on 18, 17, 16, 15, anything? I mean, we still have all week next week to discuss. If you find out like you're at home and you're like, I don't remember how to do this. I need to ask. So feel free to ask me. Number 19 is supposed to be super easy. Whenever you add and subtract fractions that have polynomials, the denominators have to be the same. But the way we learned it this year, they all were always the same. Notice the denominators here, 2n minus 3, 2n minus 3 on both sides. So all I basically have to do is just put them together. Okay, I may have to distribute that negative though right here, because that minus is going to affect these two numbers. Not the bottom, just the top. So if I rewrite this, this would just be 2n minus 3 on the bottom. You just copy what it says on the bottom as long as they're the same. And then on top, it's going to be n minus 1 minus n minus 3. Well, n minus n cancels. Negative 1 minus 3 is negative 4. So my answer is negative 4 over 2n minus 3. And let me get that and fix the box. But those are pretty easy. I don't mind adding and subtracting fractions when their denominators are the same. That's simple. When they're not the same, that gets harder. That's what we just did on the other problems, right? So those are a little bit tougher. All right, 3 more. Like I said, this one was going to be long. I know it was because of the fact that there's a lot of fractions in it. Thankfully, 20 is kind of like 19. Notice the denominators, they both have a 2x squared plus x. So that means I don't have to worry about factoring or anything like that. I'm just going to add them together. Their denominators being the same allow me to do that. So when I do this, I'm just going to write 2x squared plus x because it should stay the same. But then I just have to add them. Now remember, when you add, when you distribute the addition, it doesn't change anything. It's only when you distribute a subtraction. Okay, I have no idea why. I just noticed. I don't know why that plus is so far to the right side. That should be like right here. Don't know why I did that. Anyway, but yeah, when you distribute that the positive in, it's not going to change anything. When you distribute a negative, it changes stuff. So just be careful. Pay attention to the sign in the middle. So this will be 3x plus 2 plus 5x. Well, 3x plus 5x, that's 8x plus 2. The bottom is 2x squared plus x. And we're done. Two more. And we're done. But if I remember correctly, I think today is one of the worst days in terms of review because there's a lot of factor before you do work, factor before you do work. So right here, we're going to factor before we actually do the work. Notice this is a fraction divided by a fraction. Okay, so let me rewrite it. It's going to be 2p plus 10 over 2, but let me factor the top. That's 2 times p plus 5 over 2 times, so I just factored the 2p plus 10, I took out a 2. And then I'm going to flip the other fraction. On top, it's just going to be p plus 2. On the bottom, well, I got to factor that trinomial, so I'm going to have to do that like on the side, right? So let's see what happens with this trinomial here. A is 1, B is 6, C is 5. So this will be 5 on top, 6 on the bottom. That's plus 1 plus 5. So that'll be p plus 1, p plus 5. So let me go ahead and write that out. P plus 1, p plus 5. I left it in green so you can see that came from the side work, okay? So what can be canceled? What can I get rid of? The p plus 5. There's one more thing. The 2. So what's left on the left side fraction? Nothing. So what do I put? Do I put a 0? No, what do I put? What holds a place if nothing's there? A 1, right? A 1. So this becomes a 1, okay? So it's 1 times p plus 2 over p plus 1. I should have done that in red. I'm sorry, but we'll just leave it. So that's basically just this. This is our answer. I don't mind these that much, even though there's factoring in it. But canceling is simple when you do multiplication. So I don't mind it. These are kind of nice. I don't like the addition subtraction ones as much because, as you saw, you got to multiply through and cancel things out. But these, I don't mind. I don't think these are too bad. Personally, okay? I'm not going to say that they're easy for everybody. I like these. These aren't so bad. All right, last one. So this one is already multiplied for us. Notice it's already been factored for us. So that's kind of the nice thing. There will be questions like that on your final exam where all the work has already been done. All you got to do is finish it off. Okay? What can I cancel for number 22? The 2x. Okay, that's gone. Anything else? X minus 1. Is that it? It looks like it, right? Let me rewrite. 1 over x plus 2 times 3 over 1. That's basically what's left. Okay? So this becomes 3 over x plus 2, and we're done. So this is day 2, final review. Okay? So let me go ahead and pause it. So